things all been bad, and the world just seems so sad. I ain't had much else going on, so I sat down and wrote this song. I miss my mom, I miss my dad, I miss the road, I miss my band, giving hugs and shaking hands. It's a mystery, I suppose, just how long this thing goes. There'll be crowds and there'll be shows, and there will be light after dark. Someday when we aren't 6 feet apart. Thought we'd share that song with you this morning by Luke Combs that he wrote for what we're going through. So with that right now, let's head into graphing and solving systems of linear and quadratic equations. So first of all, recall that anytime we're working with a system, it's always two or more equations with two or more variables that have a common solution that will satisfy each equation in the system. So in a linear quadratic system, there's one linear equation and one quadratic equation using the variables of x and y. Now, our outcomes can vary. The solution to a linear quadratic system can have two solutions, okay, which we see here in system A, and that is the 2 points of intersection. That indicates that it is those two ordered pairs that will satisfy both of those equations. It can have one solution, which means it intersects at exactly 1 point, or it can have no solutions, meaning that it has no point of intersection between the line and the quadratic. So it could have two solutions, one solution, or no solutions. So let's get some practice in on how to find these. Let's start by how to find the solutions by graphing. So we have our quadratic y equals x squared and our linear function y equals 4. So in order to graph these, we're going to need to come up with a table of ordered pairs. Make sure we can get a couple of our points. So for the y equals x squared, let's go -2, -1, 0, 1, and 2. So when we plug in -2, the quantity of -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So let's plot those ordered pairs. And as we can see, our axis of symmetry is at the origin, so we're going to see that reflection. Connect it with our smooth curved parabola. Now the line of y equals 4, we don't necessarily need to create a table of values for that, because when y equals 4, that means the only thing that can change is the x value. So the line of y equals 4 is the horizontal line where y is equal to 4. So now as we take a look to get our solutions to solve, we see that there are 2 points of intersection on the graph. So therefore this will have two solutions. And our first solution is at the ordered pair -2, 4. And our second solution is at +2, 4. So recall I mentioned that if we plug both of those in to both equations, it should satisfy them. So y equals 4, we see that that holds true. But let's go ahead and prove that they work in y equals x squared. So that means 4 should be equal to 2 squared, which 4 does equal 4. It works there. And if we also plug in then the -2, -2 squared also equals 4. So there's some proof that it does work in both. Okay, let's go ahead and try another one. So we have the same quadratic, y equals x squared. So we already have our table of ordered pairs. So let's go ahead and just replot -2, 4, -1, 1, origin, 1, 1, 2, 4. for y equals negative 4x minus 4, we can make a table of values, or we can graph using slope-intercept form. So my y-intercept is negative 4, and our slope is negative 4. So that means we're going to go down 4 and to the right 1, which is going to go off of the graph. So I'm going to do the inverse, and I'm going to go up 4 to the left 1, up 4 to the left 1. I'm going to go ahead and draw in our graph. And we see on this one that we have exactly one solution. It is crossing at negative 2, 4. So remember, that means that this is the only ordered pair that should make both equations true. So let's give it a quick proof. So if y equals x squared, that means 4 should be equal to negative 2 squared. 4 equals 4. Let's try it in the linear equation. Y equals negative 4x minus 4 to give it a check. So 4 equals negative 4 times negative 2 minus 4. Negative 4 times negative 2 is 8. And 8 minus 4 is 4. So we see that it works in both equations. So that's graphing by hand.